In question 48, you are looking at a scenario where they produce potato chip bags. They tell us that they have the bag states that it's 10 ounces. They tell you that it is approximately normally distributed, the weights are. And they tell you that there's an average of 10.2 ounces in each bag with a standard deviation of 0.12 ounces. Now, this would be if I were to select one random bag from the whole population. Walk in to the factory and grab a bag off the production line and test it out. What percent would I expect to be underweight? So we have to kind of explore that idea. If I'm going to look at underweight things, right? So for part A, underweight, let's draw out the distribution. They tell us that it's normally distributed. What's the center of this group? It's 10.2 ounces. What qualifies something to be underweight in this situation? Well, if you're the manufacturer and you put 10 ounces on the bag, and like, hey, it's got 10 ounces in it. If it's underweight, it should be less than 10 ounces. Right? And so if we wanted to find out the percentage of bags that are underweight, then I'm really looking to find out the area less than 10 with a mean of 10.2 and a standard deviation of 0.12. What is the operation that we use to solve this? Normal CDF. Okay? And from the picture and the information, it's pretty obvious what we're supposed to do. All right, negative 1 E99 is the left value. It goes all the way up to 10, with 10.2 is the mean, and 0.12 as the standard deviation. Notice, my sample was of size 1. So I don't need to readjust my standard deviation or anything like that. It's just going to be what it is. Turns out, well, you tell me, what's the percentage? Yeah, it's going to be 0.0478 approximately. Okay, part B. Here, it's asking, some of the chips are sold in bargain packs of 3 bags. What's the probability that none of the 3 are underweight? We did this back in chapter 15. When I tried to find the probability that none of them are underweight, then what we're going to do is we're going to try to find out the probability that at least one was overweight. And it looked like this. All right, so part B, what's the probability that at least one is overweight? Well, what did we find in part A? We found the probability that one was underweight. So what's the probability that something is overweight?
1 minus.
Yeah, so 1 minus 0.0478 would tell us the probability that it would be overweight. So how many of these do I want to find?
3.
So I'm going to take that result. Because each bag is packaged independently, we can just multiply that together. Right? So that whatever that probability is, it's like 0.9522. If I cube that, that's getting 3 bags, at least 3 bags that are going to be, one of them is overweight.
0.863.
So you get 0.863. And so the probability that none of the bags are underweight would be probably getting 0 bags that are underweight. They would be 0.863. So 86.3% of the bags. If I were to go in there and choose 3 of them at the same time, that's a chance that all of them are over 10 ounces. Pretty good chance, which you would expect to be that. Okay? That's the tricky part. Although that's kind of extra. That's not really part of this chapter. Part C, although it is. Let's go back to look at that one. Part C says, what's the probability that the mean weight of the 3 bags is below the stated amount? I want you to take a second and look what word in that question is the most important word. if I were to take this, this is what's the probability that the mean weight of the 3 bags is below the stated amount. We just moved in from a single distribution to a sampling distribution. This question is going to be almost exactly like question number 1, or part A, but instead of a sample of 1, we're finding averages with a sample of 3. So what do you think we're going to do? We're going to change our standard deviation. And so if I redraw, listen to get off of yellow. If I redraw the distribution, we're still at 10.2 ounces. But now for my standard deviation of X bar, remember this is quantitative. We're talking about weight, quantity, right? And so my standard deviation for this problem is going to be the population standard deviation divided by the square root of the sample size that we're averaging together. And so in this case, it's going to be 0.12 divided by the square root of 3. This is the most important step in this chapter. This is one of the most forgotten pieces too. When I do that, we get 0.069. I'm still looking at here at 10 ounces. And I want to know what's the chance that, so take in mind for a minute, if you were to walk into a factory and just randomly select a bag from the production line and check its contents for weight, the chance that you found one bag that was underweight was 4.78, so just under 5%. So not very often, right? For every 100 times you do this, you're only going to find it about 5 times. So not very often at all. What's the chance that, what I'm telling you now is I'm going to walk into that factory, I'm going to pick 3 different bags randomly. What's the chance that their average is all underweight, which means I'm pretty much picking all of them that are underweight? That's more likely or less likely to happen? A lot less, right? You don't want to find just one. Now you want to find 3 at the same time that has an average that's underweight. So they don't all have to be underweight, but they have to be underweight enough to average less than 10. So let's find out what that probability is. We're going to go down here. We're still going to use normal CDF. And it's going to be the exact same as before, except what? My standard deviation is going to change. So it's going to be -1 E99. And we're going to have up to 10 still as defining to be underweight. We're going to have an average of 10.2. But now comes in the point where I'm going to change the standard deviation because now we've increased our sample size, which makes the variation go down. Center stays the same. They told me from the beginning that this was normally distributed. Oh, by the way, we should back up. I'm using normal models, and I didn't check to see if that's okay. Look up in your notes real quick. For quantitative measures, how do we know if I can use a normal model or not? We can't use success and failure. It's large enough, right? So let's just run through this. Random. Do we have any reason enough to believe that I have a random distribution here?
Yes.
We believe that it's random bags. I don't have any reason to think that the bags that I selected were biased in any way, right? That makes sense. What about independent bags? We have a good reason to think that all bags are packaged independently. Yes? One bag's weight isn't going to impact another bag's weight, okay, for the most part. We have 10%. Well, we have a sample of 3, so 3 times 10 is 30. Do you think there's more than 30 bags at any point in time in this production? Yes. Absolutely, right? So 30 is less than 10% of all bags. And then the last part, the most important part, is, do I use success or failure, or do we use a different one?
Different.
Success and failure is for categorical data. This is quantitative. What is the quantitative one called?
Large enough sample.
For large enough, what did we say had to be true?
The original population.
I gave you two things to look at.
Not.
So, yeah, the first part is like, well, I want to make sure that I've got a large enough sample. But if you go back and look at the original statement, I have a sample of 3. 3 is not bigger than 40. So I can't use that. However, they did tell me right here, the bags are believed to have a normal model. If they tell you that you have a normal distribution, I can assume that the sample is also normally distributed for small, even for small samples. And that's just kind of what we have here. Okay? And so if we go back, let's finish this out, right? So stated. And see what I did here? I wrote down how we justified the assumptions and conditions. I kind of abbreviated things. You can write it out in more detail on your paper. But I've got to justify them. And I can't put a checklist down. I got to kind of write out why I believe that it's normally distributed or not, or why I believe that this has been satisfied or not. Okay, you've gotten the calculators out. What's the probability? Let's go back up here to normal CDF. What did you get when you used 0.069 as your mean? Or standard deviation? 0.0, what was it? Yeah, it rounds to 0.0019. So if you move that to a percentage, you've got less than 0.2% of a chance of walking into the factory and selecting just 3 bags that are all underweight. They're not that frequent. They shouldn't happen. Okay? And so that would be the answer to part D. Or, sorry, part C. Sorry. If we go to part D, what's the probability that the mean weight of a bag, a 24 bag case of potato chips, is all below 10 ounces? Try this one. I'll give you a few minutes. We're going to take this one, and we're going to do it just like we did last time. We're looking at using a sample of 24 with the same mean and the same standard deviation, original standard deviation, and we're going to be finding out the probability that it's an underweight group of 24 bags. This should feel, when you look at the problem, that this is extremely unlikely to occur, which is why we get 0. Right, so you're going to be taking your new standard deviation, dividing it by the square root of 20, or you're taking your old standard deviation, dividing by the square root of 24 to create your new standard deviation. That's the key element that you're going to be able to do and to make this work out. It's a lot like question A or even question C, but here we're having to modify the standard deviation because we've now taken a sample of 24 and averaged them out. Sometimes when we get a z-score of, or a probability of 0, we think that we get if we have a probability of 0, it makes us think that we may have gotten a mistake somewhere. We're going to be able to take our z-score and justify our solution of a probability of 0 that it makes sense. If we can figure out that we have a very large standard deviation or a large z-score, whether that's positive or negative, then we can show that we have an unlikely chance of occurring. Its probability would be basically 0 or 1, depending on which direction you're coming from. So we're going to plug in our values. Oops, not 0.10 or 0.110. We're going to change it to 10 and 10.2. So this is our x value of 10, which marks off the being below underweight, and 10.2, which is our average. And then we're going to go in and calculate our standard deviation and put that in the bottom and then divide. I got a z-score of negative 8.16. Make sure that you do this calculation first, because if you don't use parentheses and you type this in, you're going to get something a little bit weird. Okay? Do 0.12 divided by the square root of 24 first, and then do your 0.1 divided by 0.102. When you do the subtraction, do the division, you come out with this thing, this crazy small or large z-score. Your calculator actually rounds it to 0. Your calculator goes to quite a few decimal places. It's telling you that even as far as it goes, it's still 0. So there's almost no chance that you're going to walk into a store or a factory and pull out 24 bags and it'll all be less than 24 or less than 10 ounces. It's just not going to happen. They don't occur often enough.